So in this video, we're going to look at two aspects of astrophotography that are key to obtaining sharp images. The first one is polar alignment, and that is aligning the mount with the Earth's rotational axis. An equatorial mount counteracts the rotation of the Earth, and the more accurately you have that mount aligned, the more precisely it will hold the stars steady in the image. And this is important when you're doing long exposure photography. The less movement of the star, the sharper the image is going to be. And the second point is focusing the telescope, again with the objective of obtaining the sharpest possible image. In this video, I'm going to show you how modern software makes each of these steps relatively easy. So firstly, the polar alignment. Here is an image to help you visualize what we are trying to achieve. We want to get the mount's main rotational axis, which is the RA axis, the right ascension axis, perfectly aligned with the Earth's rotational axis. If we are in the northern hemisphere, we will be using the north celestial pole to help us do this. In the southern hemisphere, we will need to use the south celestial pole, because either side of the equator we cannot see the opposite pole. So this is the instruction manual for the Skywatcher HEQ5 mount, and on page 10 it takes you through the polar alignment process using the internal scope. It tells you how to align the scope and then how to use the reticle to get an accurate polar alignment. We don't need to worry about that now because we have software that makes the task much easier. The software that I'm going to be using tonight is SharpCap Pro, and I'll take you through the polar alignment routine step by step, and you'll see just how easy it is. It looks like the sky will be clear tonight, so I have set up the telescope, and what I plan to do in this video is show you how we can obtain an accurate polar alignment using software. Because I'm in the southern hemisphere, I have the telescope pointing roughly towards the south celestial pole, which is up in this direction. Once it gets dark and we can see stars, I will use the polar alignment feature in the SharpCap software to precisely align the mount. If I was in the northern hemisphere, I would be using the north celestial pole. In reality, the back of that telescope is now pointing to the direction of Polaris. Perth is 32 degrees south latitude, so Polaris is 32 degrees below the horizon to the north. So to prove this point, here is a time-lapse video taken with a P900 last year from the same location in Perth facing north. You can see that the point of rotation is well below the horizon. So we're now going to run the polar alignment routine, and for this to work we need a rough polar alignment, which I did by eye earlier today. The mount is connected to the software and the camera is taking a 2.6 second exposure, allowing us to see sufficient stars. We go to the Tools menu and Polar Align. At this point we just follow the steps. I click the Next button. It is now identifying the stars in the frame, and from that it knows where the south celestial pole is. So it's ready for the next step. Now it's saying to rotate the RA axis, and the polar alignment error has not yet been calculated. So I'm going to rotate the axis with the software, and I generally move it around 90 degrees. Now at this point, the software is able to calculate the error. You can see we have 51 arc minutes of error, so less than 1 degree. After doing this many times, I can generally eyeball the alignment to within 1 degree. We now click Next, and it tells us precisely what corrections are needed. You'll see that most of the correction is needed to the left. It is saying only 12 arc seconds down, because the actual angle set for 32 degrees doesn't really need to change. But when I put the mount inside and then I place it out on the balcony again, I may not have it pointing exactly true north. And that is exactly what we're seeing here. So I need to move it by 51 arc minutes to the left. Now the mount has alignment knobs here. I can do that, but I can also just move the leg very slightly with my calibrated finger. Okay, needs to go a bit more. So after several minutes of very careful adjustment, you can see I now have an excellent polar alignment. It's basically just fluctuating a couple of arc seconds. And that means the mount is going to track stars extremely accurately. So once I'm satisfied with the accuracy of the polar alignment, the next thing I do is precisely focus the telescope. We're going to do that with a Batinov mask and a bright star. So I'll now point the telescope towards Altair. It is currently up there. You probably can't see it in the iPhone, but I chose that one because it puts the focusing wheel on the telescope in a nice position. So there's the star, and as you can see, it is reasonably well focused already. I just did that focus again by eyeball for the polar alignment. Now we're going to make it extremely precise. So there's the Batinov mask. I think I'm pronouncing that correctly, but let's check with an expert.
Павел Бахтинов. Павел Бахтинов. Павел Бахтинов. Павел Бахтинов.
We place that on the front of the telescope. And you'll now see 3 lines. The objective is to get that center line precisely between the other 2, and the software will help us do that. We go to Tools, Focus Assistant, and Batinov mask. It then carefully analyzes the position of those 3 lines and helps us make an adjustment. The idea here is to get that graph as low as possible and that number as close to 0 as possible. So very small adjustments, and then watch the result. Okay, we're getting closer. A little more. Okay, you can see we've just gone a fraction too far, but I just let it sit there for a few cycles, and if it oscillates either side of 0, we have it about as accurate as we could hope for. And that's what's happening. So I'm satisfied that the telescope is now focused as precisely as possible. We can remove the Bahtinov mask. There's no need to touch the focuser, and we now have everything in perfect focus. Let's take a look at the moon. Select moon and slew. Now with this exposure value, the moon is going to be extremely overexposed. The other thing we need to do is change the tracking from sidereal rate to lunar rate. There you can see everything is overexposed. So I need to turn the gain right down and the exposure on the camera down as well. And as you can see, the moon is nicely in focus. And this is something that flat earthers still don't understand. If you have the exposure value set correctly to see the moon, you will not be able to see stars. Let's just go back to Altair at this exposure value and see what happens. Going back to sidereal rate. Where are the stars? We can't see anything. The telescope is pointed straight at Altair, but we can't see it because we had the exposure value set accurately for the moon. Now we can turn up the gain and we can turn up the exposure. Lo and behold, the stars appear, and lots of them. So hopefully some of that information is helpful if you're considering getting into astronomy yourself. It is another beautiful clear night here in Perth. There is the moon and there is Jupiter. But tonight I'm focusing on the south celestial pole. I plan to leave the telescope running all night, taking one frame every 7 seconds, and then we can compile that into a time lapse with star trails. In my next video, I'm going to do a review of an astrophotography camera known as the SV Bony SV305. And there it is, fitted to a 130mm Newtonian telescope. And this is to show you that you don't need expensive equipment to obtain good images. This is a very inexpensive yet good quality camera, and this is an extremely basic telescope. I'll talk about them more in the next video, but here is a quick preview. So here is the SV305 on the Newtonian telescope looking at the moon, and we're getting some beautiful sharp images. If I zoom into 200%, you can see the detail is nice and clear. I better go inside before I start changing.